My name is Gustav Hallegraaf, and I'm a professor at the Institute of Marine and Antarctic Study of the University of Tasmania. And I served as the editor-in-chief of the Global HAB Status Report. The first approach that we took was to select different experts in different regions of the world and ask them and their teams to produce an overview of HAB problems in their part of the world in the period 1985 to 2018, where possible supplemented with historic records. These results have been published in a special issue of the journal Harmful Algae, which came out in February of this year. The ultimate goal of this initiative was to answer once and for all big questions that have been raised in our HAB discipline for the past 30 years. Are harmful algal blooms increasing? Are they increasing in global distribution, in frequency, in intensity, in impact on human society? And if so, what are the driving forces? And important factors that have been raised are climate change, eutrophication, and anthropogenic transport via ships, ballast water, and other factors. So for the first time now, we have a solid database where we can start to try and answer these questions. So HADAT at this point in time includes some 9,500 records of HAB events with an impact on human society. About half of them are high phytoplankton abundances and water discolorations, but also mass mortalities, mucus, and the other half are seafood toxins. And the seafood toxins partition here in 37% paralytic shellfish toxins, about an equal number of diuretic shellfish toxins, and lesser numbers of other toxin syndromes like amnesic shellfish toxins, ciguatera, cyanotoxins, and so on. That's a global overview. Then we looked at the globe as a whole and broke it up in some 12 to 13 different regions. We refer to them as OBRIS regions, like the West Coast of America, East Coast of America, Central America and the Caribbean, South America, Europe, Mediterranean, Benguela Current, Indian Ocean, Southeast Asia, North Asia, Tropical Pacific, and Australia and New Zealand. And then we looked at those data region by region. First, the type of HAB events, and in some regions you get equal numbers of about seafood toxins, the blue bars, and high phytoplankton abundance, the green bars, but in other regions, seafood toxins are the only problem. Here we partition the seafood toxins again into the different syndromes, and you can see here differences are even more pronounced. Some regions like Southeast Asia are almost entirely dominated by paralytic shellfish toxins, these purple bars, but in other regions like Mediterranean and Europe, we have a dominance of diuretic shellfish toxins. And not surprisingly, in the tropical Pacific, ciguatera is the only problem of real concern there. So this is the first hint that we probably should not talk about HABs. It's a global phenomenon. We should look at them at least region by region. Then we started to look at trends. So these are the key categories of HAB toxin syndrome, dinophysis, and here are the number of occurrences of dinophysis records in the period 1985 to 2020 coming from OBIS. It's an increasing number, and that's reflected in an increase in the number of HADAT events that refer to diuretic shellfish toxins, either high dinophysis numbers or the detection of toxins. But what of course really counts is where in the world are we really seeing impacts on human society? So these are real numbers of human poisonings indicated by these shellfish icons. And it's very difficult to predict from the occurrence of an organism, the presence of toxins, where the key impacts are going to be. Here, the same thing with Pseudonychia. Look at 128,000 records of Pseudonychia. That also includes some of the non-toxic species, with a rapid increase in awareness, reflected an increase in HADAD events, but still there's only one major toxin outbreak that affected human poisonings. Here, Alexandrium, nearly 20,000 records, an increase in paralytic shellfish toxin. And when you look at this distribution map, comes from Obis Mapper, this undoubtedly is the major HAB toxin syndrome that is causing problems with a lot of human poisoning events indicated with the shellfish icons. And then we started to look at the number of data in the system, both HADAD and OBIS. And here I did seek the expert opinions and help from my Australian colleague, Anthony Richardson, who's a professor in mathematics at the University of Queensland. And he helped me with conducting very complex meta-analysis. So here we look at the number of HADAD events by region over that same 30-year period. And not surprisingly, most regions we see a significant increase in HADAD reports. But here we do a meta-analysis. And how this works, we see here we did meta-analysis of the number of HADAD events against year. And how this works, here we have an error bar. This is the average, this is the range of correlation coefficients, but what really counts whether these bars are separated from this zero line. And only when that's well separated, this is a significant correlation. And you can see region by region, none of those correlations are significant. Only when you look at the global total, it's the power of large numbers of data. Yes, there is a significant increase in HADAD reports over time. We did it in another way where we looked at the number of geographic grids that had one or more HADAD events per year. We did a similar meta-analysis, and this correlation is only very weakly significant. So we can't really state categorically that there has been a global increase in the distribution of HADAD events, but there is an increase in the number of reporting. Then we started to look at one of the first key drivers. So these are data on aquaculture production in different parts of the world. We grouped them slightly different. So East Coast, West Coast America, significant increase, South America, and Central America and the Caribbean, an increase, Australia, New Zealand increase, Southeast Asia, a major increase in aquaculture production. In Europe, it peaked around 2000 and actually is going down. It's probably not enough coastal water left where you can put in fish or shellfish farms. And then we did a similar meta-analysis where we took the meta-analysis of HADAD events against year, and we also linked that in with aquaculture production increases against year. And globally, this is a very significant correlation. So this tells us categorically that a lot of this increase in HADAD reporting is correlated with an increase in aquaculture production. How this works, increased aquaculture production leads to more intensive HAB monitoring, and that's what drives that correlation. These are the most interesting data sets. Now we are aware that we have to correct somehow HADAD records for the intensity of monitoring. We here did that by looking at OBIS data on all microalgae as a proxy. There are about 6 million records of microalgae in OBIS today, and in most regions of the world to actually increase. And here we corrected HADAD events for the intensity of monitoring efforts in a different region of the world. And in some regions, yes, there's still an increase visible, these orange arrows. In some regions, there's actually a decrease, but in other regions, there is no significant change at all. And again, we just throw all of the powerful statistics at it. And here, this is maybe somewhat of a surprising result. When you look at the global data set, there is no significant change in HADET events over years when we corrected for differences in the intensity of monitoring. So these are the conclusions. Some of it is quite obvious, but it's important to spell it out. There are many different HAB species that we are aware of that all respond to different environmental factors. And we probably should look at this data set species by species and region by region. So looking for uniform global trends, we couldn't find them, but it doesn't really make sense to look at the data like that. But yes, there are some regions where we have picked up emergent new problems. They're indicated with some of those asterisks, like, Alaska is warming up and showing changes in HAB behavior, Ciguatera turning up in the Canary Islands, and so on. And again, some of these new phenomena, they really attract a lot of media. And those two factors, increased monitoring, increased aquaculture, and the media attention for a number of new emergent impacts, that really drives this perceived global increase in HABs. The next stage of this work is to superimpose upon our data sets and maps climate change models. So this is here a climate change model that predicts by the end of the century major temperature increases in those hotspots here in red. And another major data gap that you still need to fill is data on eutrophication. Increased aquaculture also drives nutrients, and we need to fill in maps like this of the two key drivers, climate change and eutrophication, to answer these questions of HAB increase and who does it once and for all. Thank you for your attention.